So in Module 2.5, we're going to take a look at the last type of graph used for data, which are box plots. So first we're going to review percentiles, and then we're going to talk about box plots. So a percentile is a number where a certain percent of values fall below that number. So percentiles are used a lot in standardized tests, the medical field. So it describes what percent fall below that number. So for example, you receive your score on the ACT and you are in the 89th percentile. Is this a good percentile? So the 89th percentile means 89% of people scored below you. So this would be a good percentile. So this is a case where being in a high percentile is a good thing. It's not always a good thing to be in the high percentile though. So like if you're an adult and you go to the doctor and they say you're in the 90th percentile for cholesterol, as an adult, that's bad. It means 90% of people have a cholesterol level lower than yours. So that's a bad. So just because you have a high percentile doesn't automatically mean you are, it's a good thing. So our second example says a 1-month-old baby goes in for a checkup and is in the 20th percentile for weight. Is this a good percentile? So that means 20% of 1-month-old babies weigh less. So this is probably not good. So typically for percentiles when it comes to babies for weight, when you're that young, you want to be somewhere above the 50th percentile. So obviously 50th percentile would mean average. So being in the 80th percentile for weight as a baby is not as much of a bad thing as if you're an adult and you're 40 years old and you're in the 80th percentile for weight. So again, percentiles are very context-based. It's very dependent on what the context is and what the situation is. Okay. So what we're going to talk about next is a box plot. And it's a graph that displays the, it's something called the 5-number summary. Of a data set. So box plots are used to display percentiles. So the 5-number summary, 5 numbers that make up percentiles. So the first one is called the minimum, which is your smallest value in your data set, also known as the 0th percentile. It's not really referred to that in a lot of places, but it technically is that. The next one is what we call quartile 1, which is also just abbreviated Q1. It's the middle of the values below the median. It's also known as the 25th percentile. Then we have our median, which we've already discussed is the middle of your data set, also known as the 50th percentile. Then we have something called quartile 3, also known as Q3, and it's the middle of the values above the median, also known as the 75th percentile. And then lastly, we have our max, which is the largest value in our data set, referred to as the 100th percentile. Now, in situations, we don't actually have a 100th percentile. We usually say 99.99 or 99th percentile. We don't usually say 100th percentile. We don't like to be in absolutes like that. And then the last thing we have is something called the interquartile range, which is abbreviated IQR. And it is the range of values that are in the middle for 50% of your data. So the IQR is calculated by taking quartile 3 and subtracting quartile 1. So it gives you the range for the middle 50%. So right below that, we kind of have a graph of what a box plot looks like. It's also, you might have heard of it before, referred to as a box and whisker plot. So we start with our minimum, and then we have what's called a whisker to our quartile 1, and that's what forms the box. And the box starts with quartile 1 and ends at quartile 3, and then at some place we put a line for the median, and we have another whisker to our max. And then that interquartile range is that distance from quartile 1 to quartile 3. Another thing with box plots is we can determine shapes of distributions based off the box plot. So wherever the median falls in relation to the quartiles, like if it's closer to quartile 1, that usually lets us know that it's skewed right. And if it's closer to quartile 3, that lets us know that it's usually skewed left. And then if the median is in the middle of our quartiles, that usually tells us that our distribution is symmetric. So we can still tell the shape of a distribution from a box plot. So let's go ahead and take a look at an example. So we have a random sample of 10 boxes of raisins and their weights in grams. We want to find our 5-number summary, construct a box plot, and then determine the shape of our distribution. So the first thing I'm going to do, I'm going to write we have to do min. I'm going to always abbreviate quartile 1 as Q1, the median, quartile 3, and then our max. So when you're finding the 5-number summary, the easiest ones to start with are the min and the max. And thankfully our numbers are already in order. So my min is 25, my max is 38. The next thing we have to find is our median. So I'm going to start by crossing off numbers. And then I end up with 30 and 34, and the middle of 30 and 34 is 32. When I go to find quartile 1, I break up my data in half. So every number below the median I use to find quartile 1. So I have to use 25, 28, 29, 29, and 30. And I cross those off. So quartile 1 is 29. And I do the same thing for quartile 3 with the numbers above my median, 34, 35, 35, 37, and 38. And I get 35. Okay. Now that I have my 5-number summary, I'm going to create my box plot. So the first thing I do is I create a number line. Okay. And I can start my number line wherever I need to. So in this case, we typically start at our minimum, which is 25, and then we can pick a scale to go up by. And I'm going to go up by 2s. I do need to give it an axis, like title. I need to know, okay, what is this? And it's going to be weight in grams. So I'm going to start by making my line for my min. Then I'm going to do my whisker to quartile 1. Then I'm going to create my box to quartile 3. And then I'm going to label my median, 32. And then go to my max, 38. So min, quartile 1, median, quartile 3, max. And you don't have to label these things when we construct a box plot. It is known that that's where these things are in a box plot. So you don't have to label them every time. So now when I'm looking at my shape, I'm looking at between quartile 1, median, and quartile 3. Is my median in the middle between those two? Is it closer to quartile 1, closer to quartile 3? So 32 is exactly in the middle between my quartiles. It's 3 from each of them. So that tells me that the shape of the distribution is symmetric. So let me know if you have any questions about percentiles, box plots, calculating the 5-number summary, or any of that.